Look at the pile of sawdust sitting in the corner of your workshop. Like most people, you probably see nothing more than a messy nuisance. You sweep it up, stuff it into a plastic bag, and haul it to the curb on trash day. But what if that same pile of dust is actually worth more than the solid lumber it came from? And what if mixing it with a simple $3 powder from your local hardware store could transform that sawdust into a block harder than pine, stronger than commercial particle board, and built to outlast the house you are standing in right now? Welcome back to The Roots Survived. Today, we are uncovering a legendary technology that has nearly been forgotten. A construction method the modern billion-dollar lumber and cement industries quietly allowed to disappear for almost a century. This is not some modern science experiment. It is an old, independent way of building that the Amish never stopped using. The first time I saw it, I was standing inside a tall, sunlit barn just outside New Wilmington, Pennsylvania. On a dusty workbench sat what looked like an ordinary rustic brick. Then an Amish elder named Amos stepped forward, lifted a heavy framing hammer, and tapped the block. It did not answer with a dull thud. It rang with a clear, resonant, almost metallic note, like a piece of solid stone. I stared at Amos in disbelief. He simply smiled, the corners of his eyes folding gently, and said, "Sawdust and lime, that is all." At first, I did not believe him. But after years spent searching through dusty archives, testing old bulletins, and building with my own hands, I do now. By the end of this video, you will know the exact time-tested ratios recorded in a forgotten 1918 USDA bulletin that most modern builders have never heard of. You will know how to press your first stone-like block in your own garage this weekend. And most importantly, if you already own a home, you will discover how this slurry can help cut heating costs, seal drafts, and protect your walls from pests. This is about more than saving money. It is about recovering a lost piece of human capability. So grab a cup of coffee, settle in, and let us explore how ordinary waste can be turned into nearly indestructible stone. Part 1. The Encounter and the Amish Miracle. To understand how this knowledge disappeared, we have to travel to Lancaster and Holmes County, where Amish families have lived quietly, remaining largely independent of the power grids and commercial supply chains that control modern life. Walking into Amos's workshop feels like stepping through a doorway into another time. There are no humming power cords, no screaming air compressors, and no plastic-wrapped rolls of fiberglass insulation. There is only the warm, rich scent of freshly cut wood, the steady rhythm of hand tools, and a deep, unshakable sense of self-reliance. When Amos placed the block in my hands, the first thing that surprised me was not its hardness. It was the weight. The block was remarkably light, nearly 1/3 lighter than a standard clay brick, and unlike concrete, it did not feel cold or lifeless. It felt unexpectedly warm in my hands. Amos told me that his father had pressed that very block during the summer of 1962. Think about that for a moment. A block made entirely from waste wood dust and an inexpensive mineral powder had been sitting inside a damp barn for more than 62 years. There were no cracks, no discoloration, no soft areas, and no signs of rot. It still carried a faint, familiar smell, like the forest floor after a fresh autumn rain. How many commercial materials can you buy today that would survive 62 years of humid summers and freezing winters without a drop of paint or sealant, yet still look as if they had just come off the production line? So why did we stop building this way? Why does improving a home now seem to require a huge trip to a big box store, a second mortgage, and mountains of synthetic, toxic materials? The answer is simple, but sobering. The world was standardized to turn people into consumers instead of creators. An independent farmer who could press his own blocks from mill waste and use them to build smokehouses, spring houses, and chicken coops did not fit neatly into a standardized market. So the knowledge was allowed to fade, left to yellow inside the basement archives of agricultural universities. But the earth did not forget, and neither did Amos. Part 2. How sawdust turns to stone. So what is really happening inside this mixture? How can a loose, powdery pile of sawdust become a mineral block built to last? The answer begins with that inexpensive powder, hydrated lime, chemically known as calcium hydroxide. When dry sawdust is blended with hydrated lime and given a small, carefully controlled amount of water, a slow and patient chemical process begins. That process is called carbonation. Unlike modern Portland cement, which hardens through rapid hydration, lime cures by breathing. It draws carbon dioxide directly from the surrounding air, the same gas we breathe out. Over weeks, months, and years, calcium hydroxide gradually combines with carbon dioxide and becomes calcium carbonate, the same chemical material found in natural limestone. In other words, every microscopic wood fiber becomes surrounded by a crystalline shell of solid limestone, formed from the air inside your own workshop. This chemistry is far from new. 2,000 years ago, the ancient Romans understood the same carbonation reaction. They combined lime with volcanic ash to build the dome of the Pantheon in Rome, a massive concrete structure containing no steel reinforcement. After 20 centuries of earthquakes and storms, that dome still stands. Amos's family did not have volcanic ash, but they had wood fiber in abundance. The wood serves as the aggregate, giving the material flexibility and remarkable thermal insulation. The lime forms the mineral matrix, creating the hard, stone-like protection around it. But for the reaction to work correctly, you must understand what Amos calls the fist test. He told me, if you can teach a 10-year-old to pass the fist test, they can build for the rest of their life. The mixture of sawdust, lime, and water must never become wet or runny. When you squeeze a handful firmly in your fist, it should keep its shape like damp brown sugar, without a single drop of water pressing out between your fingers. If the mixture is too wet, you drown the lime. If it is too dry, carbonation cannot properly take place. It is a lesson in patience, balance, and learning to listen to the material in your hands. Part 3. The secret liquid. If you speak with Amish families across Lancaster County or around Berlin, Ohio, you will discover that nearly every family has its own small variation of the block recipe. But there was one legendary secret that took me almost 2 years of visits to fully understand. It was not something they added to the sawdust or the lime. It was something they mixed into the water. Some families told me they used sour buttermilk. Others insisted on the liquid whey left behind after making cheese. An elderly grandmother near Holmes County said her mother always used the cloudy, starchy water left after boiling potatoes. What could these ordinary kitchen byproducts possibly have in common? Chemically, they contain proteins and starches, especially casein and whey proteins. When buttermilk or whey is blended into the mixing water, the casein protein bonds with the calcium ions in the lime. That reaction creates a powerful organic-inorganic compound called calcium quinite, an exceptionally tough natural plastic. It is the same type of chemical binder used in ancient European frescoes, whose brilliant colors and structurally sound plaster have survived for more than 600 years. The casein works as a natural waterproofing agent. It seals the microscopic pores in the lime block and prevents moisture from breaking down the wood fibers trapped inside. It can increase the overall compressive strength of the cured block by an astonishing 60%. I eventually found written confirmation of this obscure method in a yellowed, out-of-print 1934 Penn State Extension Circular, number 187. It had been written for dairy farmers who had more leftover whey than they knew how to use. The university recommended turning that dairy waste into on-farm building blocks, and cited compression tests that dramatically outperformed traditional mixtures. The circular was quietly discontinued in 1938, and was never issued again. Ask yourself why a simple, nearly cost-free technique that allowed farmers to become more self-sufficient would be left gathering dust in a basement archive. The answer is obvious. No one can patent dairy waste and sawdust. Part 4. Choosing the right sawdust. Before you rush into the garage and begin dumping sawdust into a bucket, we need to talk about wood species. This is where many modern do-it-yourself builders go wrong, and it is a detail you will never see printed on a bag of commercial cement. Not every kind of sawdust behaves the same way. Pine sawdust is the easiest to find, and it works beautifully, but only when its natural sap is respected. Fresh pine sawdust cut that same afternoon still contains active resin and sap that work against the lime. The sap tries to seal the wood fibers, preventing them from absorbing the lime and water slurry. Amos told me about his great-great-grandfather, who learned this craft from an old-world stonemason in 1847. One year, the family hurried to make enough blocks for the entire winter using green pine brought directly from the local mill. For the first 6 weeks, every block looked perfect. Then the damp spring weather arrived. The blocks began to sweat, split open like eggs, and the family lost the entire shelter. From that day forward, one rule inside the Amish workshop became absolute. Pine sawdust had to rest in an open bin for at least 90 days. It was turned once every week, so the active resins could settle before the fibers ever touched lime. But if you want the gold standard, look for oak sawdust. If you can collect oak shavings from a local cabinet shop, you have found something valuable. Oak naturally contains tannins that bond with lime in a way pine cannot match. An oak and lime block cures about 11% denser, producing greater load-bearing strength and improved fire resistance. Maple can also be used, but its fibers are exceptionally short, so the sawdust must be ground much finer. Amos runs maple dust through an old hand-cranked flour mill until its texture looks almost like powdered sugar. Walnut requires special attention. Walnut sawdust contains a compound called juglone, which is highly toxic to plants. And although the lime eventually neutralizes it inside the cured block, breathing walnut dust during dry mixing is dangerous. Amos always covers his face with a wet bandana and rinses the walnut shavings in water before beginning. These are the small, practical details that separate failure from success, the living knowledge carried through generations. Part 5. William Mason and the Steam Cannon. To understand the full potential of wood fiber under pressure, we need to look at one of the most remarkable accidents in American industrial history. The story begins with a young engineer named William Horatio Mason. Mason was a brilliant Cornell-educated inventor who eventually became a personal protégé and apprentice of Thomas Edison. During the early 20th century, the timber industry was facing a serious crisis. Vast stretches of virgin forest had already been clear-cut. Replanting had started, but everyone understood that it would take generations for those trees to become large enough for lumber. Mills were running out of usable logs, while enormous mountains of discarded sawdust and wood chips continued to grow. Mason became obsessed with finding value in that waste. He understood that wood fibers behaved very differently when exposed to steam and extreme pressure. Mason was also a showman. To present his idea to wealthy timber investors in Laurel, Mississippi, he built what could only be described as a steam-powered cannon. The machine was made from a 15-inch steel shaft. He loaded it with rough wood chips and water, sealed it, and heated the chamber to a blistering 480 degrees Fahrenheit, creating 600 pounds of pressure per square inch. When Mason pulled the heavy release valve, the sudden explosion of pressure tore the wood chips apart, separating them into a soft, fluffy mass of pure wood fiber. But the true breakthrough came by accident in 1924. During a long testing session, a pressure valve on Mason's experimental hot press malfunctioned. Steam slowly leaked into the chamber, holding damp wood fibers, while Mason stepped away for lunch. When he returned, he expected to find a ruined batch. Instead, he opened the press and discovered a hard, dense board. Testing showed that this accidental panel, made entirely from exploded wood fibers held together by the wood's own natural lignin, was stronger than the original timber from which it had been made. Mason had accidentally created masonite. The industry now understood that wood waste held enormous power. But rather than teaching ordinary people how to press their own building blocks, large manufacturing associations pushed aggressively to standardize construction around costly, mass-produced lumber and sheet products. Independent building was dismissed as unprofessional. Yet the underlying science never changed. Wood fiber is an extraordinary material. Part 6. Type S versus Type N, lime. Now let us discuss the most important purchase in this entire project, hydrated lime. This $3 to $7 powder becomes the mineral binder that holds the stone-like blocks together. When you visit a hardware store or agricultural supply center, you will probably find two different kinds of hydrated lime on the shelf, Type S and Type N. If you remember only one detail from this video, remember this: you must use Type S hydrated lime. Type S, meaning special hydrated lime, is chemically processed under intense heat and pressure. That process ensures that every molecule of free calcium oxide becomes fully and completely hydrated. The finished product is highly stable. Type N, meaning normal hydrated lime, is a weaker and cheaper material used mainly for whitewashing barns or reducing acidity in garden soil. Type N is only partially hydrated. If Type N is used in sawdust blocks, small pockets of unhydrated calcium oxide may remain trapped deep inside the pressed material. Months later, as humidity slowly works its way inward, those pockets suddenly absorb moisture and expand with tremendous force. A beautiful, stone-hard block can swell from within and eventually crumble into dust. Amos told me that his grandfather once drove a horse-drawn buggy more than 40 miles to a particular mason's yard outside Lancaster just to purchase Type S lime. He refused to use the inexpensive Type N sold at the nearby country store. 40 miles in a buggy for a $5 bag of powder. That tells you how important the correct grade truly is. Do not compromise here. Read the label carefully. The bag must say Type S hydrated lime or Mason's lime, and handle it with respect. Hydrated lime is a highly alkaline caustic powder. During dry mixing, it produces a fine dust that must not enter your lungs or eyes. Always wear a proper dust mask and heavy gloves while handling the raw material. Once it has been mixed with water and fully cured, it becomes inert, non-toxic, and safe. But during construction, safety must come first. Part 7. How to press your first block. Now, are you ready to press your first block this weekend? Let us go through the exact physical recipe Amos's family has used for 6 generations. Begin with 1 5-gallon bucket of dry, properly rested sawdust. Pine or oak works best. Add 1 1/4 gallons of Type S hydrated lime, roughly 1 1/4 gallons of clean water, and 1 cup of inexpensive buttermilk or whey. Measure by volume, not by weight. Amos was firm about this. Weight measurements can fail because sawdust naturally draws moisture from the air. Sawdust stored in a damp workshop becomes heavier, which may lead you to add too little water and produce a brittle, crumbling block. Volume is more forgiving. It is the method the old builders trusted because it worked. First, prepare the mold. A simple rectangular mold can be built from scrap 2x4s or pine boards in about 20 minutes. For a test block, an ordinary bread pan also works well. Coat the inside with a very thin layer of linseed oil or used motor oil, so the finished block releases cleanly. Next comes the dry mix. Pour the sawdust and lime powder into a wheelbarrow or large plastic tote. Blend them with a garden hoe or rake for at least 4 steady minutes. Continue until the entire mixture becomes one uniform pale tan color. If you still see white streaks of lime or dark pockets of sawdust, keep mixing. Now prepare the wet mix. Stir the cup of buttermilk into the bucket of clean water. Add this liquid slowly to the dry ingredients, about 1 quart at a time, mixing thoroughly after every addition. Perform the fist test often. The material should feel like thick, damp oatmeal. When squeezed, it should stay firmly together without releasing any water. Then fill the mold. Spoon the mixture in, using 3 separate layers. After adding each layer, press it down firmly with a flat block of wood. Amos's father taught him to tamp every layer 30 times. Finally, begin the curing process. Leave the block inside the mold for exactly 48 hours in a covered area protected from direct sunlight. Sunlight can dry the surface too quickly and create cracks. After 48 hours, tap the mold gently and slide the block free. Place the block in a cool, shaded part of the workshop. Stack it with spacers so air can move freely around every side. Allow it to cure for at least 28 days. After 90 days, it reaches its full, stone-like strength. Part 8. Home insulation and cost savings. If you already own a home and are thinking, I do not need to build an entire barn, stay with me, because this next part is meant specifically for you and your utility bills. Nearly every home has cold spots, drafty corners, unfinished attic areas, or gaps near the foundation-grade beam. You do not have to tear out drywall, hire an expensive contractor, or apply for a building permit to deal with them. Mix a small, fresh batch of sawdust and lime slurry, but make it slightly wetter than the block mixture. The texture should resemble a thick, spreadable putty. Using an ordinary trowel or putty knife, press the material directly into cold gaps, drafty corners in the crawl space, or the open area behind a basement water heater. It dries in place, closes the draft, and creates an insulating value comparable to 2 inches of commercial fiberglass. Unlike fiberglass, it will not sag, rot, or burn, and mice will not touch it. The reason is that the highly alkaline cured lime irritates the sensitive pads of their paws, turning the material into a powerful pest barrier. I used this method in my own cold basement 3 winters ago. A gap behind the electrical panel allowed January air to blow directly into the house. I combined 1 gallon of sawdust, 1 quart of lime, and a splash of buttermilk, then packed the mixture firmly into the opening. The very next month, my gas heating bill fell by $41. Now consider the remarkable economics behind this method. Building a standard 12 by 16-foot backyard workshop or garden shed with retail materials today, drywall, fiberglass rolls, vinyl siding, and dimensional lumber, can cost between $11,000 and $14,000. Amos built his entire 12 by 16 workshop from sawdust blocks pressed in his own yard. His total out-of-pocket material cost was exactly $342. That amount covered the lime, some mortar cement, several sheets of tin roofing, and the hinges for the door. $342 for a building that may still be standing when his great-grandchildren are old. It is termite-proof, fire-resistant, and maintains a remarkably steady indoor temperature throughout the year because the sawdust core performs like 12 inches of solid fiberglass. It is a triumph of independent engineering. Conclusion. On my final afternoon inside Amos's workshop, I asked him a question that had been on my mind for a long time. I wanted to know whether he believed the modern world was going to collapse, and whether all this self-sufficiency and homesteading was really preparation for some enormous catastrophe. Amos stopped working. For a long, quiet moment, he looked at me while chewing a piece of hay. Then he said, "No, the modern world is not going to collapse. The modern world is going to keep humming along just fine for the people who can afford it." He glanced around the workshop and continued, "What is going to happen is that a lot of good men are going to spend their entire lives working jobs they absolutely hate, just to pay for things they could have made themselves. And when they finally retire, they will be too tired to enjoy any of it. That is the real catastrophe. That sentence has echoed in my mind every day since. The world keeps moving exactly as it does now, while good, hard-working people spend their one precious life earning money to buy things their grandfathers once made for pennies, with nothing more than a bucket and a shovel. The world will always sell you what you can make yourself. That is the whole business. Once you truly understand those words, you cannot forget them. You begin to see their meaning in every aisle of every store. You begin to recognize a lifetime of small payments made for things whose raw materials were sitting in your own backyard all along. The Roots Survived is about reclaiming that lost capability. It is about taking back control of your home, your energy, and your life, one small block at a time. So try it this weekend. Find a bag of Type S lime, collect some free sawdust, squeeze the mixture in your hand, pass the fist test, and press your first block. Next month, when you tap that cured stone and hear it ring like metal, something inside you will change. You will realize that you are a little less dependent than you were yesterday, and that quiet confidence may be the greatest inheritance of all. Tell me in the comments, do you already have a bag of sawdust sitting in your workshop, or will you collect some this weekend? I read and reply to every comment, and make sure you subscribe, because our next video explores one Amish method for keeping a root cellar at exactly 52 degrees Fahrenheit throughout the year without using a single watt of electricity, using something most people throw away every autumn. After that, we will look at how the Amish preserve meat without refrigeration for as long as 18 months, using nothing more than salt and smoke. You will not want to miss either one. Thank you for watching. Keep your roots deep, and I will see you in the next video.